Hello everyone, this is your guy Rajat from RenuStudios.com. So in today's video, we are going to talk about Node.js streams and what kind of problem you can actually address using streams. Also, make sure you watch this video till the end, because at the end of this video, I'm going to teach you how easily can you create a simple media streaming server using Node.js and within 5 minutes. So without any further ado, let's get started. So why should we use streams and what type of problems can stream address? So let's consider that you have this big file sitting on your server. So the file size of that particular file is around 4 GB, right? But using the default Node.js server, you cannot just serve that kind of big file using Node. So you need some sort of mechanism which allows you to efficiently serve the file without using all of the available memory and the CPU power of your server. So let's have a quick example of what I am talking about. We are going to get back to our code editor and we are going to write a simple program which will demonstrate what I am talking about. So let's quickly write it up. I'm going to create a writable stream, and that is going to write a file. Now let's suppose I want to write a big file, and that file is going to write hello world for 10 million times in a file. So let's quickly do it, and once we are done writing the file, we should end this stream. Okay, so this is a simple program. Let's quickly save it. Basic.js. Okay, so this is a basic example where I'm trying to write hello world to a file for 10 million times. So let's see what happens. Before we do that, let's quickly start the system monitor so you can get to see the effect of running this program on my system. Node.js basic.js. Okay, and press enter. Okay, so we have to use the clause use strict so that Node.js can process const and lets, because it is not supported in the legacy mode. Okay, and let me clear this up. Clear. And now we are going to run our program. Okay, so just notice the surge in the memory consumption and the amount of CPU that is being used. As soon as we hit the enter, the amount of memory consumed by our program increases, and it is also using a great deal of our CPU processing power. And as you can see that we have got some error in the background. So let's quickly see, like as you can see, process out of memory. So we have hit the high water mark, or you can say the highest limit of memory a Node.js process can use due to running this sort of unoptimized program, and we were not able to write the file, and there is nothing in the file. So what actually went wrong in this program? The thing is, file.write is going to write everything in the buffer, and once this sort of loop finishes, it is going to flush the data to the file. And since this loop is going to iterate for 10 million times, we surely are going to run out of the memory, and we cannot contain that amount of data in our memory. Okay, so that is why this program failed to work. So that sort of problem can be easily solved using Node.js streams. Okay, so let's quickly have a look at the solution of how we can efficiently solve that sort of problems. So this is an optimized version of that very same program. In this program, we first check that whether our write return a true or a false as an answer. When it returns true, it means that it was able to write into the buffer and the buffer's limit is under control, and we haven't hit the high water mark or the limit of whatever data our buffer can contain. Okay, if it returns false, it means that we have probably hit the high water mark and we cannot write to the buffer anymore. Okay, so it is just a simple check, and based on the check we are going to fire a drain event. I am going to talk more about events in later part of the video. And as soon as we are going to encounter a false as the result of this statement, we will register a drain event listener. Now drain is an event which is available on write stream, and it can get fired once our buffer is ready to accept more data. Okay, so once our buffer is free and it can accept more data, this drain event is going to be fired, and once the drain event is fired, the writer callback is going to be called, and this is the writer callback itself. So let's quickly run this program and see for ourselves, like, is this program efficient enough? So Node.js basic chunk. Okay, and let's keep a close watch on our system monitor this time. So as you can see that our memory consumption is not going to be increased by an exponential amount, and there is a small amount of rise in memory consumption and CPU power, but still that amount is sort of acceptable, right? And we have finished our process without any errors, and as you can see that our CPU usage and memory consumption have dropped. So let's quickly see that whether we were able to write the file successfully this time or not. Okay, so Atom is going to take a lot of time to load that file, so quickly use vi editor to do it, vi file. Okay, and it is also going to take some time, and let's set the line number so that we can see that whether we have written 10 million lines or not. And let's quickly go to the end of the file. Alright, so we have written 10 million lines to this file. Okay, so that is how you can use streams to write efficient programs where you can deal with large amount of streaming data. Now there are 4 basic type of streams in Node.js. The first one is the read stream. The read stream is an abstraction of a source from which you can read the data. So you can consider a file stored on your server as a readable stream. Now a write streams is an abstraction of a destination which you can write to. Okay, so as in our earlier example, we have created a write stream, and that write stream is going to write all of the data to a file, and that file is also a destination of where this stream should write data to. Okay, and the third one is the duplex stream. Now duplex stream is a combination of these two, so you can read the data from the duplex stream and you can write the data to the duplex stream as well. Okay, now the fourth one is that transform stream. In transform stream, you can actually read the data and transform the data according to whatever criteria you have. Now suppose you are getting 1, 2, 3, 4 and so on as your input data, and you want to calculate the squares of this incoming data. So you can easily address that sort of problems using transform streams. Now we are not going to talk about duplex and transform streams in this quick tutorial because that is going to make this tutorial very long and cumbersome. So I'm going to demonstrate the use of read and write streams, and then you can go onto the internet and have a look of how easily you can implement duplex and transform stream, provided that you have the foundation of read and write streams. Now all streams are the instances of event emitter class. So whenever there is some sort of action on the streams, it is going to emit some sort of event. Like in our older example, we have used once.drain, so there are events like that. Now as soon as some type of action is going to happen over your stream, an event is going to be fired. On read stream, there are events like data and end. So data gets fired whenever some data is available in a buffer and you can read the data. An event like end will be fired when there is no more data to be read from the read stream. Now for writable streams or write streams, there are events like drain and finish. Now we have already talked about the drain event, which indicates that the buffer is able to accept more data now, and you can buffer and read the data from the read stream and buffer it into the write buffer. Okay, and finish is going to be fired when there is no more data to be written to the writable stream. And there are certain other type of events for this write and read stream, which you can easily check out from the Node.js's streaming documentation, and I will leave a link to that streaming documentation in the video notes, so make sure you check the video notes out, and will also upload code samples from this tutorial on GitHub. So I will also include the links to that code samples in the video notes, so make sure you check the video notes out. Now you know that what are streams and what kind of problems do they solve, and what are some of the streaming events. But there is an easy way to consume the streams. That way is known as pipe. So it is very similar to what pipes do in Unix and Linux environments. So if you write something like ls pipe wc-l, which is going to count the number of lines written by this ls statement. Okay, so 5, because we have 5 files available in this directory, right? So you can write same sort of thing in streams, where you can pipe the input from a readable stream as an input to a writable stream, and that writable stream can treat that data accordingly and write to the writable stream. Okay, so let's quickly test an example. Now we are going to write a simple one-line program which is going to emit the same thing you are going to provide as an input. So it is as simple as writing process.std in, which is an abstraction of Unix's input stream. Okay, so it is going to read the data from our console, and we are going to pipe the data to a process.std out. So this is a readable stream and this is a writable stream, and what we are doing is simply passing or piping that readable data over to the writable stream, and that writable stream is going to return the output. Okay, so let's test it. Like I am going to write HELO, and as you can see that everything is being written twice, because the first H is the one I have entered and the second H is the one which has been output by the writable stream due to this piping. Okay, so what it is actually doing is it is actually emitting whatever I am throwing at it. Okay, so this is how this thing works. Now this was a very simple example of how you can consume a readable stream right from the writable stream using pipes, and how you can route the readable stream's data over to a writable stream. But what if you want to do some sort of custom processing over the input data and produce the output accordingly? So for that we can implement streams. Now to write a custom implementation of streams, we are going to require a stream package. Okay, so let's stream. Okay, and for the input we are again going to rely on process.standard input, which is a readable stream, and for the writable stream we are going to write a custom implementation. Okay, so stream dot writable. Okay, so this is a constructor which we have to use in order to implement custom streams and custom functions for our streams. So we are going to write a new implementation of a writable streams, and in this stream we are going to pass an object which contains a write method. Okay, so this write method is the heart of how your custom writable stream is going to process the data. So it has signature like this, and CB is the callback here. So chunk is the data we are going to receive from the readable stream. So we wanted to calculate the length of the input data. So let's quickly write something like Okay, and then we are going to call the callback. Okay, so we have implemented a custom writable streams, and now we can tell this implementation like how do we actually want to process the input data that is being read from a writable stream. Now we can simply plug the data to our custom implementation pipe output. Okay, now we have written our program, so let's test it. Node.js and reading. Okay, so now it is accepting our input. Let's quickly write this and press enter. So as you can see, the output is 5 because THIS are 4 characters and we have pressed entered as well, so that enter is going to be accounted and included in this string. Okay, so that makes 4 plus 1 equals to 5, and we have got 5 as an answer. So we can test it again, like we are going to input is and we are going to get 3. So this is how you can efficiently write custom implementation of readable, writable and whatever streams, and then you can write how you actually want to process the data according to your business requirements. Also, we know that we can react on the events fired by our streams, so let's quickly spice this program up by writing an event listener which is going to write by whenever we send the closing command or the sigint command, which is equivalent to processing control D, which tells a Unix process that it has to be closed. So we are going to write a friendly by whenever user requests to close the input stream. Let's test this program. This program is working fine as expected, and let's press Ctrl D to end this program and send the end signal. And as you can see that now we are getting a friendly by from our program. So in this example we have learned about piping, trapping and reacting to streams events, and how you can easily implement streams to write your custom solution according to your business cases. Alright, so with that we have reached to the conclusion of how easily you can use Node.js's streams to write your programs. Now it's the time for the bonus. Now I'm going to teach you how easily you can stream a media file using Node.js. So this is the code for our media server. Now first of all we are requiring file system module and HTTP module from Node.js's core modules. Okay, now what we are creating here is that we are creating a simple HTTP server, right? So this is the code to create a simple HTTP server. Now this argument is a readable stream and this argument is a writable stream. So our request is a readable streams and our server can actually read data from that stream, and response in a similar way is a writable streams, and we can write data to this response stream. Okay, so what we have done is we have opened a read stream to this file. Okay, let it be any MP4 file. Now we have set one header, that is content type equals to video MP4, which means that we need to tell the client that whatever data it is going to receive is a video and it can play it back accordingly. Okay, and then we write the header over to our response stream, and then we are going to pipe our read stream to the writable stream, that is response stream. Okay, and it is as simple as that. Now quickly run this program and see whether it is working according to our requirements or not. So Node.js media server. Okay, and we have booted up the server. So as you can see that our video has started playing. So that is how easily you can stream a media using Node.js. So with that we have reached to the conclusion of this tutorial plus bonus example. and I am sure that you might have got some sort of idea about what node streams are and how can you use these sort of thing for your advantage and to write efficient programs. So this is a part of our Node.js tutorial series, and if you are interested in knowing more about Node.js and what event callbacks are and things like that, make sure you check out the other videos from this playlist. And if you are interested in learning JavaScript, I also have one more playlist where I have taught basic JavaScript for beginners, right? So maybe you want to check that out. Also, make sure you subscribe to this channel because I produce weekly computer tutorials and software industry related videos, and also like this video. And with that, this is your guy Rajat Saxena signing off. Take care. Bye bye.